Welcome to this walkthrough of Printago's file management and slicing system. Today, I'm going to show you how Printago handles different file types and explain our unique approach to slicing that will save you tons of time. If you're new here, Printago is cloud-based print farm software built specifically for Bambu Lab printers, but we're working hard to add support for Prusa, Clipper, and more. One thing that sets us apart is our approach to handling files and slicing. We're much more than just a G-code slinger, like other solutions out there. For today's demonstration, I'll be using a real product example, a set of track risers for kids' wooden train tracks. I'll show you how to add the same parts to Printago in a few different ways, and you'll see how Printago can improve your workflow, no matter how you like to work. Let's dive in. Printago supports all the major 3D model file formats. I'll demonstrate each one using our example. Let's start with basic STL files. Here, I have pre-rendered files for each of the 8 different parts of our example. We'll leave the slicer setting on printer default for now and come back to how we configure the parts for slicing later. When you upload parts to Printago, they're stored in our cloud and ready to be assigned to any printer. We don't pre-slice your models or require G-code. Instead, slicing happens on demand when you assign a part to a printer. This means you only need to upload your model once, and it can be printed on any printer in your farm without creating multiple G-code files for each printer model, bed type, and so on. With Printago, you can forget about managing G-code altogether. Just manage your models and your slicer settings. After they're uploaded, it just takes a second to queue all of them up for printing to our mixed farm of Bambu X1, E1, A1 Mini, and A1 printers. The parts will each be sliced on demand when they're assigned to available machines. In the default configuration, each part will be sliced using the printer's default settings. All print jobs are processed through our smart queue, which we've affectionately named Gutenbed. Next, let's look at 3MF files, which are pretty much the new standard for 3D printing because they contain more information than STL files. Printago preserves all that info like seam painting, modifiers, and so on, while still allowing you to send your files to any printer. For our track risers, I've got a project file with all the risers arranged on 3 different plates for my X1 and P1 printers. Printago automatically detects and imports all 3 plates from the file and gives you nice little thumbnails to know what the plates look like. A key feature we've added is slicer version detection. Printago automatically detects which slicer and version was used to create the 3MF, whether it's Bambu Studio or Orca Slicer and which version. It'll set the slicer drop-down to the appropriate setting for the part. Printago also gives you the option to use the process slicer settings directly from within the project file instead of one of your synced slicer settings from the desktop slicer. This means you can manage slicer settings just within the 3MF files themselves if you prefer that workflow. When printing 3MF parts, just select which plates you want. You can edit each plate individually or adjust them all at once. Building SKUs using 3MF plates works exactly the same. Next, let's talk about OpenSCAD. OpenSCAD files are parametric models defined by code. Looking again at our train track pieces, I have a single OpenSCAD file that can generate all 8 different riser parts. After I upload the SCAD file, there's a few extra fields than when we add STL and 3MF files. Printago will look for any included or used libraries or font files and prompts me to upload them. Also, we parse the file for input variables defined in the SCAD file. Because Printago offers native OpenSCAD rendering, we can dynamically generate models based on parameters. I have this OpenSCAD file all set up, so all we do is tell it which piece we want, 1 through 8, and we can provide it with a brand name to embed into the model, and it will generate that STL. Let me demonstrate by selecting piece number 3 and adding Head Concepts as the brand name. This parametric capability is perfect for customization. Imagine setting up a trophy model where your customer can specify a name to be engraved. Printago will automatically generate the model with that custom text when the order comes in. After the part is generated, it's queued and will be sliced automatically, of course. This is a powerful feature in Printago and really sets us apart from other solutions on the market. Later this spring, we'll also allow you to define colors parametrically. Finally, we'll give a shout out to G-code 3MF files generated by Bambu Studio and Orca. We support them, including the multi-plate variants, and they work very similarly to regular 3MF project files with one exception. They're locked to whatever printer they were sliced for and will only ever be sent to printers of that make and model. While we do support G-code 3MF files, they don't let you take full advantage of Printago's dynamic slicing capabilities that we're about to explore. In traditional print farm software, you need to slice your models for each printer type in advance, creating multiple G-code files to manage. If you have different printer models or filaments or build plate types, which we all have of course, it can be a nightmare. Let's say you have a Bambu P1P, an A1 Mini, and an X1C. You have one part you want to reliably produce after figuring out your slicer settings. If each printer has two different build plate types, you're already up to 6 G-code files to manage for a single part, let alone if you want to make it out of more than one material. Now, just imagine if a new slicer setting came out that you want to take advantage of. Maybe new fuzzy skin options or scarf seams? Well, time to update your G-code library, or do what most folks do. Give up and reslice files every time they print them, reducing themselves to grand operator of the desktop slicer. Printago takes a completely different approach. After being added to the queue, jobs wait for an available matching printer. After they're assigned, they're sliced and sent to the machine. Each model only needs to be uploaded once. Each printer is pre-configured for slicing with familiar profiles for printer, filament, and process configuration settings. You'll find default profiles as well as any of your custom ones we've synced from your Bambu Lab cloud account. Let me show you this in action with our train track parts. I'm going to assign different parts to the 3 different printers we talked about: an A1 Mini, a P1, and an X1C. Here you can see the A1 is set to use a 0.28mm layer height profile. The P1P is using a 0.2 profile, and the X1C is set to 0.16mm. Earlier, when we added our STL files, we left the process profile setting set to printer default. So, these are the settings that will be used when we print this part. I could just print a single copy of the file to each of the printers. Instead, I used our tagging system to create a dynamic group of printers ahead of time. Now I can simply print 3 copies of the STL to printers tagged with Riser Demo. This is another cool and powerful feature of Printago because you can change the tags around after the parts are queued up. So as your needs change and printers free up, you can optimize them easier. I'll pop back up to the queue, but these printers were already available and marked as clear and ready in Printago. So these jobs are already assigned and slicing. At any time after the job is sliced, you can just click the thumbnail to bring up the preview screen. Downloading the G-code from this screen will let us verify that each part was sliced just as we expected. Here's where it gets even better. In Printago, you can set slicing parameters at the part level, which will override the default settings of any printer the part is printed on. For example, I can set this riser part to always print at 0.28mm layer height with ironing enabled, even if the printer's default is 0.16mm. I can also specify filament type requirements right at the part level. This means you configure your part once, and those settings follow it to any printer it's assigned to. No more recreating slicer profiles for each printer model. As you've seen, Printago's approach to file management and slicing saves you hours of redundant work while giving you more flexibility. The best part? Printago is completely free forever for personal use. Our commercial plans aren't based on how many printers you connect, but how many jobs Printago will process from the queue at once. We'd love to have you join our community. Check out the links on screen and in the description to join our Discord, where you can chat directly with our founders and help shape the future of Printago. If you found this helpful, please hit that like button and subscribe to our channel for more videos about Printago features and updates. Happy printing!
Through the grid lines I weave and dart, electric veins fire up my art. Laser beams and circuits glow. Printago runs the data flow. From the mind to scattered parts, turning sparks to 3D hearts. Get precision in